My name's Matt. I'm with E+E Elektronik here in the U.S. The U.S. office was established in 2010, and we've since expanded to various other regions. At least, as I say, expanded, we've added salespeople to those regions. The key to our product is really in how we manufacture, what we manufacture and develop. So our bread and butter is thin film technology. We actually manufacture this in-house. We do it in the same manner, using the same type of silicon wafers that Intel and AMD and Samsung produce their microprocessors. We take a wafer of silicon, we etch it using chemicals, using various types of light, and we are able to create different products out of that. Primarily, those products are designed to detect humidity within a room. So that's really where we have the best amount of control when it comes to product development. We do all of the engineering and development in-house. We have our certified quality management system. We follow all ISO, IATF, various environmental policies as well. But the key being is that from the standpoint of the Austrian government, we are a certified manufacturer of environmental technology. We just so happen to make sensors that are useful in HVAC, industrial, and other types of applications. The business areas that we focus on can really be broken down into two: sensors and then elements and modules. Elements and modules meaning the actual devices that we produce in-house that then get assembled into the sensors themselves. So the elements include CO2 sensors and humidity sensors. Those are the primary devices that we actually put together and build from scratch from raw materials in-house. The sensors themselves, like I would say most companies, we build the technology, and then some of the other components we do manufacture, but we source various types of polycarbonate cases or LEDs, so there's a lot of assembly work, just like a lot of other manufacturers do. Within those sensors, we can really break it down into two different categories, one being the HVAC side that I highlighted, and one being the industrial side, which is more of the stainless steel, robust, heavy-duty types of products that can withstand high pressure, high temperature. That's really what I want to focus on. What we develop in terms of the technologies and why we develop it is because we really want to focus on a very narrow range of sensing capabilities, right? So 8 different measure ends is really what we focus on: air velocity, CO2, dew point, flow, humidity, moisture and oil, pressure and temperature. We don't manufacture the pressure sensors, and these are mainly an ancillary product that's built onto these so that we can get more accurate readings. But the key to a lot of this is they all stem from similar technology. Air velocity uses a resistive type temperature sensor that we actually build in-house as well. CO2 uses an infrared LED and a sensing element that looks for a very specific wavelength of light that I'll get into. Flow and air velocity are very similar because they use the same core technology. It's just air velocity is going to be in a wider room, but a flow is measured down into a certain contained diameter of a pipe, so you can understand the amount of mass of air that's flowing through at a certain given time. Dew point is another way to say low humidity, so we actually do the humidity manufacturing ourselves. And then the moisture and oil is no different than humidity and air. Air and oil both being dielectrics, right? So they actually don't conduct electricity. So having a sensor designed to look for water is no different if it's in the air or in oil. And then the temperature sensors, when it comes to the air velocity, we manufacture those in-house. But for more of the general sensing, we purchase platinum RTDs. Those are very readily available in the marketplace. It's not something that we really need to do in-house. Those are practically, the saying goes, bulletproof, right? You can literally toss them in the mud, clean them off, not clean them off, and they're still going to work. So it's tried and true technology. Really, where we start to draw our distinctions from what we purchase to what we assemble to what we manufacture ourselves is really in the core technology, which again is these humidity elements. So you can see on the probe end or the detection end of one of our products. This is an HVAC related product, polycarbonate case, circuit board, and a display. This very tip here has the humidity sensor, and if we zoom in, you can see that here. It's just a very thin piece of silicon, and what we do in that lab or in the manufacturing and production area that I highlighted is we just take those wafers and we apply a similar process to Intel, but we crack the silicon in a certain way. So there's actually, it's a capacitor based. So you actually have two conductive plates that surround or sandwich the piece of silicon. Silicon is not normally conducting unless it's under the right conditions. As moisture gets absorbed into those cracks, you're creating a bridge for the electrical current to actually transfer, right? So you're changing the capacitance of the sensor itself. And that's what's key to this technology here. And we can also then add on the temperature sensor portion of it, which is actually shown right here as the smaller element itself. And we can also transmit these values over communication technologies like Modbus over an RS-45 channel, Ethernet in some cases, but also analog channels too, both 4 to 20 milliamp and 0 to 10 volts. So we meet all industry standards in that respect, and also any type of a device this is going to be plugged into. That's on the more polycarbonate side, the HVAC side. On the more industrial grade, the EE33, which is highlighted here, is really more of our flagship product. It's been around a little while. It's a very heavy duty case. We offer versions that have two probes so that you can use it in a high humidity environment. And then this portion here, this is the same type of humidity sensors you see here, just a different size, slightly different construction. But we heat this up using what you can see is it looks like just a little coil heater sitting on the back. So we warm it just to keep it slightly above the dew point so that condensation cannot start to form on this, because metal's notorious for getting colder first when the air temperature starts to drop. And it also allows us to run a heavy amount of current through. So if there's been oversaturation of the sensor, let's say it actually has gotten wet or chemicals have been absorbed into it, we'll heat this portion to about 250 Celsius to burn off any excess chemicals, any excess moisture. And what that does is it clears out those cracks, those crevices that are embedded into the silicon that we produced, and allows that to then dry out. And as it returns to a normal temperature, it starts to absorb that moisture again and gives you an accurate reading. The reason why we have two sensors in some cases is because once you start to heat this up, you can't get an accurate humidity reading. So we have to have a separate temperature sensor that's put a distance away so it's not impacted by that. On the CO2 side as well, we do have heated versions of these, because what can end up happening, these are actual chambers that have gold plating, because we use an infrared light bulb on this end. And infrared reflects very well. Gold reflects infrared very well, so it keeps the actual light that is flashed down on this end here. Make sure all the light is concentrated within this chamber. This chamber passes through. You can see there's this white portion on both of these. This is an actual air filter, so air actually gets in, but not impurities. CO2 is absorbed by a very fine or very narrow frequency of light. And we look for that narrow band on the receiver end on this portion here. We look for that to be absorbed. And that way we know how much CO2 is actually in the system itself. Simultaneously, we have another sensor that sits alongside of it that is not affected by the absorption of CO2. So it's actually looking for a different wavelength. And what we're able to do with that is to identify how much dust has accumulated in the system, or how aged the actual infrared light has become. And we're able to make calculations that are accurate. Anytime this flashes, which is every 15 seconds, it's also doing an internal calculations to understand its own health and making automatic calibrations to ensure an accurate CO2 reading at any given point. We also have an onboard pressure sensor, because Memphis is at a different altitude than Denver. And those different altitudes mean different atmospheric pressures, which means different CO2 measurements as well. So that onboard pressure sensor is also calculated in to understand exactly what the CO2 needs to read. So we have those to compensate for. Products that these end up getting embedded into, this is an example here of our EE872, and this is a 4-in-1 sensor. It has these devices that are built in, and then it also has that onboard pressure sensor, which we can actually get reading out of that as well. And it has a temperature and a humidity sensor built in along with the CO2. This is actually one of our, I'd say, our most popular sensor right now because of its versatility and flexibility and how easy it is to actually install. And I go into that in a little bit. So you can take a standard M12 cable, screw it on, and hang it from a ceiling just by the cable itself, not worry about it overstrain occurring and the cable snapping or the M12 connection actually snapping off or that occurring. It's a very strong, robust system. We are very heavily involved in a lot of different industries. Agriculture is probably our fastest growing one. We do some in automotive, clean room technology. We do some in the United States, mostly globally. We do most of the clean room in other parts of the world. Energy technology, so moisture and oil is used in a lot of power generation plants. That includes hydroelectric, that includes nuclear. People need to know, especially on the turbine side, the status of the oil, if it's absorbed too much moisture, if there's a leak. And then on the measurement, the industrial measurement, I'll get into this in a little bit more detail, but we have a broad range of products that'll fit into this. Meteorology, any of those meteorological stations that you see on the side of the road, we probably have a sensor that's on that because we work with some of the world's top meteorological station manufacturers. And then pharma and food, we've done a fair bit in the United States, not as much as I would like, but that's definitely, especially on the food side, that's an area that we could really dive into. What I really want to dive into is the agriculture and industrial measurement. Industrial measurement because it kind of shows the breadth of our portfolio, but agriculture, because of the growth that we've seen, it's been in really one specific type of industry. So on the agriculture side, our companies or our customers focus a lot on CO2, air velocity, and humidity. Temperature, certainly that comes with it as well, but fine humidity control, especially in an indoor grow area, is really critical for a lot of these companies. They're producing a product that has to be within a certain neighborhood of humidity. Tomatoes grow at a better at a certain humidity than, let's say, potatoes. Even potato storage has to be at a certain humidity, very cold, high humidity. So we have to have a product that can withstand that. Air velocity, any type of an indoor grow, you run into the issue of microclimate. So certain areas will actually be warmer or more humid than others. And depending on what the product is or the crop, you could run into an issue where microbes are starting to grow because the air isn't circulating enough. Having air velocity sensors around certainly help to ensure that you don't have these microclimates. And then CO2, a lot of plants, well, all plants feed off of CO2. So a lot of the rooms are doped with CO2 in order to ensure that the plants are feeding adequately. Some of the products that are most popular for this that we've actually used in agriculture, from a temp humidity standpoint, there are three that I highlight. So this is the EE210. This is the new HTP 501. So you can see it's a stainless steel probe. Kind of a good upgrade from this device here. Modbus output M12 quick disconnect. Then the EE310, it's definitely one of, I would say, one of our two flagship products because it incorporates the robustness of a stainless steel probe with the flexibility that you get in a display from a programmability standpoint. It has USB built into it as well to do some levels of programming. You can also capture data, pull it out over the USB, and it's incredibly accurate. From a CO2 standpoint, we've got really two main products. This is the EE820. We have an aspirated fan that's actually in here to pull in air to get a really fast, accurate reading on this device. And then we have what I mentioned before, the EE872, which is probably the more popular, but really one of the most popular that we have right now in terms of sales, definitely the fastest growing. Then from an air velocity standpoint, we have the EE75, so industrial grade, so it can actually withstand washdown. And you can see it's got a probe here, and inside that has the dual temperature sensor that I mentioned before. That's how it actually measures airflow. So two applications really to zero in on within that industry. For the EE310, we sell a lot of these to wood drying applications. So you'll have sawmills that are really very independent from the grid standpoint because they're out in the middle of the woods. Trees get cut down, they get cut into boards, and those go into these large stainless steel type dryers. And I have a picture of one of these in the next slide. But it's a period of really high intense heat for an extended period of time, 24 to 48 hours. And what that does is it heats away all the moisture that's still in that fresh wood. So that ensures that by the time it is removed from the kiln, that it's actually ready to be sent to a Home Depot or a Lowe's to be put on the shelf and be sold. A lot of these are dimensional lumber for use in actual building and building projects. So it's very key to make sure that it's dried to a certain level so that you don't run into various types of shrinkages, or at least that it's within specifications. Cannabis for the EE872 is actually a huge industry, and a lot of our customers, especially integrators and distributors, are seeing a lot more inquiries from cannabis growers. It's not legal in every state. It's actually not even legal in half the states, but the ones that it is, there are grow operations that are sprouting up, no pun intended, sprouting up everywhere, and they need accurate measurement. This isn't quite pharmaceutical grade operations that they have, but it's pretty close. The facilities that I've been in, cleanliness is a huge concern, so these have to be able to withstand a type of cleaning. These certainly can. They can actually withstand hydrogen peroxide cleaning, but they have to really be able to measure that CO2 accurately all the time, and the temp humidity side of it. These are very quick and very accurate, and they're easy to install because of that M12 quick disconnect, and they don't take up a lot of room. So that is one of the big benefits that we provide for this. So to give you an idea of these types of applications, on the left, this is an actual dry kiln. One of our sensors would actually go kind of on the outside into various locations. What that does is it actually feeds the information back of what the humidity is, something called a wet bulb temperature reading, and it's designed to replace an old mechanical type of wet bulb system, but it's able to tell an operator how much humidity is actually in the system. And sometimes they'll drive wood down to about 15% original moisture content. So if you exceed that, the wood can start to flex and bend and get out of dimension. That also costs extra money, right? You're burning more stuff to generate that heat. It costs money. But at the same time, if you can get it out right on time, you're able to move more product in. Right now, lumber's very high demand. It's not as quick as the demand's greater than what these kilns can actually keep up with, because again, it takes 24 to 48 hours to dry a huge set of lumber. You can kind of see that over in this picture here. It takes a good amount of time to do that. So they want to be able to fit in more boards. So let's say you're able to save 20 minutes on a single one. Well, over time, you're going to build that up to where you might even be able to get in a whole nother set of boards. And then on the right side, we actually have a picture of one of our sensors in an actual cannabis grow facility. And just like I mentioned, you can see here, this is the M12 cable that's connected to the sensor itself and simply hangs. So you don't have to have any special type of a bracket. The weight of this sensor is light enough that it will never cause too much strain on this device here. So as the cannabis grows vertically, this is easy to pull up because people want to keep it at cannabis height, but that ensures that the plants are getting adequate amounts of CO2 and that the humidity and temperature are correct. From an industrial standpoint, we also get into more of the dew point side. Dew point, as I mentioned earlier, it's another way to say just really, really dry conditions. You'll see references of dew point being minus 60 degrees Celsius. So that doesn't necessarily mean the actual operation is a low dew point. Just means you'd have to have an object that's about minus 60, let's say, for any type of condensation to start to form on it. That's all that means. And we measure not just the dew point temperature, but we'll also measure the water content in the atmosphere in ppm, and we're talking probably 20 to 30 ppm in some of the driest conditions that we're able to get down to. Give you an idea of where that could be useful, right? So pharmaceutical, definitely battery manufacturing, lithium, and any amount of moisture they never mix, right? It's truly an explosive combination. And then flow. So a lot of these gases, even on the cannabis side, if you think about you're pumping in CO2, you have to generate that. A lot of the way that this stuff is generated is by burning natural gas. When you burn natural gas, you get CO2 and water. You're burning something that's kind of somewhat expensive, natural gas. You're pumping it through to go into one of the rooms to feed these plants. You want to know adequately, how much is going through. Is that costing you more than what you need? So a good flow sensor that we offer is able to do that and give you really accurate readings. So similarly, compressed air on the flow side, and also on the dew point side. Compressed air is also expensive to generate. You want to make sure there are no leaks. Compressed air goes through a dryer as well, and I get into that in a little bit, but it ensures that everything is working properly. So give you an idea of some of the products that we offer for that, I highlighted earlier that EE33, so that was a picture that I had where you could actually see the sensing element itself. Great for measuring the temperature and humidity side, and really any level of humidity. So you could be at 0% or 100% humidity, and this is going to give you an accurate reading. And that's unique for this collection of sensors, because you want to be able to, anything above 85% is considered a condensing environment. So you want to be able to really control the device that's in there to do this measurement is similar to taking a water bottle out of the fridge on a warm, humid summer day. Any change in temperature is going to cause condensation to start to form. So what we do with the sensors, we warm it slightly. That keeps it just above the dew point by just a couple degrees. That still allows water to absorb in, so you get an accurate reading. And then we have the separate temperature sensor that's here, that's positioned away, so it's not affected by that extra warmth, and you're able to get an accurate humidity reading because of that. The dew point sensors, so we actually have three within our portfolio that are true dew point sensors. This is the EE371 and the EE355. These are designed for high pressure applications as well, so they can actually handle up to about 100 bar. And they'd have this threading that's embedded in them, so they can go into various sampling cells so that the customer knows that number one, the pressure is good, but also that the air is dry within that compressor system. On the flow side, this is an actual embedded or inline system that you would actually, we have various sizes, but you would thread the pipe here and then kind of, these are two different versions, but this is an all-inclusive system here, and then this is kind of a separate, more remote style probe that can be inserted into a larger diameter. You can see this has an M12 quick disconnect on it and an onboard display. And basically there's a probe that sits underneath this, goes down into the pipe and looks for that air velocity. And it's an air velocity in a contained environment, so we're able to know exactly the volume of air or gas that's moving through it. So we're able to get very, very accurate readings in that sense. In terms of applications that are on the industrial side, so two that I want to highlight is environmental chamber monitoring. The EE33 is heavily used within that, especially when various types of chemicals are burned, because you'll get chemical condensation on top of this. And what the system allows is for you to burn that off simply by activating what we call an arc system. It's basically automatic recovery. And what that means is we heat up the element incredibly hot so it burns out any excess chemicals that are on that. So, you know, again, it's really designed for those heavy duty industrial applications. And then that dew point sensor that I mentioned, especially on the compressed airline monitoring, is able to tell you a couple things. Moisture content is really, I should say, indicates two things. You know, if you have an increase in moisture, it's going to tell you either the dryer itself has an issue or that there's a leak somewhere in which air is either leaking out and it's causing a differential pressure, which is then causing condensation to build up on the sensor. So you'll see the ppm start to rise, or at least the dew point start to increase, because now there's more moisture in the system that can start to condense on the device itself. So we're actually able to look for a lot of different measurements with that, or do some diagnoses with that as well. So kind of just give you an idea visually, you know, a lot of environmental chambers, like I mentioned, use these types of sensors in order to ensure that they're going to be able to withstand those high heat, high humidity, various chemicals that are introduced into the system. This will make sure that it's going to withstand the life of that as well. And then on the compressor side, as you can see, we have add-on features. So here's a sampling cell that can actually be plugged into any type of an inlet on the compressor itself, so it can do sampling of the line gas. But again, it's very critical when you have a device like this to make sure that the quality of the air coming through, because it's used for processes, it's used for maintenance, and it's also very costly. These use large amounts of electricity, so the last thing you need is a leak causing you more to run this system more, because it's very expensive to do so. Some of the other benefits that we have just working with E+E. So number one, we're a smaller team, but we're very responsive. For the types of products that we have, which are heavy duty, industrial grade, we will work directly with you on your projects to make sure you have the right one selected. Or if you have an inquiry from a customer, we are more than happy to help you and get you what you need. We keep items stocked on the shelf, and those products have been carefully selected to make sure that we have something that'll fit and work in pretty much any application that you might have. The easiest application all the way up to the most difficult. So it may not be the exact product someone wants, but if they need something quick and they can't wait because component lead times right now are pretty bad, but also they have to be manufactured in Austria, and even at 2 to 3 weeks, it may not be short enough. We have stuff on the shelf that we can ship out immediately to make sure that we have a solution for anyone's application. And then various domestic services that we offer. So we have the capability of repairing some sensors in-house, but really, and to highlight this device here, this is actually a humidity calibrator. Depending on the application or the industry, really regulations sometimes require sensors to be calibrated once a year. We can do that in-house here in Chicago. And what that involves is us actually plugging it into this system. It generates a very specific amount of humidity, and we're able to certify it with an actual printed certificate that the specific serial number of that part has been measured, is corrected, and is working according to the customer's expectations. So again, we can do this in-house. These are NIST traceable certificates we provide, and these machines themselves are also calibrated in Austria every 2 years, so they conform to all certifications that are required for our type of a business. And if you or your customer needs an even larger type of accredited calibration, we do offer that in Austria as well. We can do OEKD certificates, so it's just the next level up than what we're able to do here. We're also very limited to just being able to do temperature and humidity. In Austria, we can also do air velocity, CO2, even though CO2 is designed to calibrate itself over time. And we can also do the dew point as well because it requires incredibly dry chambers and conditions. Give you an idea of some available resources that we offer to our customers and our distributors. Number one, our website has been redesigned. It's very easy to use. All the latest documents and information is always updated on this. We have a very easy to use search bar. You can search by product application as well. We keep this up to date, and it's something that I actually use routinely. So, multiple times a day. We have customers that call us. I help them as well with technical requests. I'm able to go on the website, get them exactly what they need. For the cannabis industry, again, that's a very growing industry, and it's a lot of people that are very good at growing plants, but haven't had to really consider how to calculate a payback on technology. We have a white paper that's available, and you probably got a copy of that in the mail, and I can send more if you need it. But I actually have a paper here that's designed to help you explain to your customer how to kind of think about the different cost inputs from a labor standpoint, from a quality standpoint of the end product, and how they can help justify the expense of adding sensors, because it's critical to have automation for a variety of reasons, but especially from a quality standpoint too. So this kind of helps get their mind around something that's different for them. And finally, we have an updated product catalog as well. These are available. We can ship these to you. It's a very good catalog, just highlights some of the key points of our products. On our website, we have all the data sheets that are available there. But these are 3 items that I use routinely, I would say, to help customers make the right selection for sensors. What is the best sensor to use in a high, humid, but relatively clean environment? So kind of just to go back on one of these slides, so I highlighted for a high humid environment this EE33, kind of our flagship product. We actually have a version, a different version, if I kind of go back a little bit. It's very similar to this. This is the EE210. And then, I don't have to remember these part numbers, but we have the EE211, and that has dual probes on it as well. So you'll see this embedded here, and then a separate metal temperature sensor. And what that does is it allows us to heat this portion just slightly, just keep it slightly above the dew point temperature. We have just a standard resistor that goes across, and that's able to create enough heat to keep that sensor element slightly warm. And then the temperature element over here is separated enough to where it's not affected by that increase in temperature. So that's a very low cost way to do that. Another question, how long will the sensors last if used within specifications? So all of our sensors are designed to use are designed to last 10 years when used within the specific confines of the data sheet. So if we say up to 350 degrees Fahrenheit, but you're running 500, that's going to be a problem. It's not going to last as long. But if you're within that envelope, they will last at least 10 years. And kind of like I mentioned a few moments ago, we have products. In fact, we just dealt with one this week. It's an old version of the of our moisture and oil sensor, and it's at least 10 years old based on the serial number. And only now are they asking to have it recalibrated. So some of these, when they're within that envelope, are going to last a long time. Okay, if you have questions or need quotes, if you need more specialized training, if you're interested about other products, other industries, and whatever we can do to help you win business, that's what we are here for.